Hi everybody. Today I am going to discuss about complex numbers. Complex numbers may seem rather strange at first because we will be dealing with imaginary rather than real quantities. Actually, later we'll see that the equation which has no real solution can have complex solution. Very interesting points. So first, we will try to find the square root of a negative number. If a if a real number is squared, the answer cannot be negative. For an example, squaring 5 and minus 5, the result is positive. So we can say it is impossible to obtain a negative result by squaring a real numbers. So we have to deal with the imaginary number. So what we are doing here, imaginary number, we are considering j equal to square root of minus 1. It has a special property that its square is negative. And also it cannot be a real number because its square is negative. So here I have written j square equal to negative. Very important properties. Let's find the expression for the square root of 4 and minus 4 with this imaginary number. So how to do that? Say 4, square root of 4, we can write plus minus 2. But square root of minus 4, easily we can write 4 multiplied by minus 1 and then a square root. Take this square root of 4 out and this is a square root of minus 1. Now look at these positions. J equal to square root of minus 1. So we write this as j. So easily we can find the expression for square root of minus 4 equal to plus minus 2j. So let's move in the next to understand more of it. Solution of quadratic equation in complex numbers. Root will be in complex numbers. So what we will do? We will solve a quadratic equation. In general term, quadratic equation is x square plus bx plus c equal to 0. So quadratic formula we can write as this: minus b plus minus square root of b square minus 4ac divided by 2a. But condition is this a will never be 0, not equal to 0. This is very important condition. Now let's take an example. x square minus 8x plus 25 equal to 0. So compare this equation with the general equation. A means 1, B means minus 8, C means 25. Now let's find the, using quadratic formula, let's find the value for x. Very easy, only just on this formula we have to put the value for B, A and C. So I did it. So step by step if we do calculations, and here also it says b square minus 4ac less than 0. So there are two complex roots. Look at this, minus 36. It is less than 0. So we can write this minus 36 as 36 multiplied by minus 1 to get this as a j, because the square root of minus 1 will be j. So 8 plus this 36 coming out 6, square root of minus 1 by 2. So easily we can write 4 plus minus 3 square root of minus 1. So what is our roots then? Easily we can write this as our roots are 4 plus 3j, another is 4 minus 3j. These are the two roots we got. Now in the next slide we will see how we can deal with these complex numbers. So this is the equation already we have seen. The solution of the equation already we know. What was our solution? So if we look at the solution, and this solution actually it is known as complex numbers. So a complex number, say this one, it is made up of two parts. These four, it is real part, and these three, it is imaginary part, and this imaginary part, it is multiple of j. As I told, so x equal to 4 plus 3j, it is a complex number, and already I told this is real part is 4, imaginary part is 3, which is multiple of j. Now we want to get a complex number, this root in general term. Say if z stands for a complex number, so what you can write? A plus bj is a complex number. Same thing, but this is generalized form. Here real part is a, imaginary part is b, which is multiple of j. We need to also understand another point, which is called complex conjugate. What is complex conjugate? Very simple. Here I have written, because we got two roots here. One is 4 plus 3j, another is 4 minus 3j. So it says these 4 minus 3j, it is the complex conjugate of 4 plus 3j. So if we have this root, so if we are asked to find a complex conjugate roots, so surely we know only the thing is we'll change the sign. In place of plus, we'll put minus. So it will be the complex conjugate of this 4 plus 3j, which is with plus. Same way, if we are asked to find the complex conjugate for this complex number, so what we will do? Because z equal to a plus bj, then complex conjugate will be, we put here z, at the top I put one bar here to indicate it is a complex conjugate. Z bar it will be, only I will change the sign, a minus bj. We will see here regarding multiplications and division of complex number. They are very important when we will do multiply or division, how to do that. So multiplications of complex number, let's take two numbers, two roots, z1 equal to 1 plus j, another z2 equal to 3 plus 2j. Two complex numbers here. We want to multiply these two. So it's very easy. Say z1 multiplied by z2, it will be simple multiplication. Look at, very easy. 1 will be multiplied here, total, j will be multiplied this total. Only the here point is to understand this, when j square will get, we'll put here minus. That's the thing here. Other 3 and 2, it will be added 5j. So 3 minus 2 1, 1 plus 5j. Now if we want to find, say, J2 bar, already I discussed J2 bar, it is complex conjugate. So only the thing what? If Z2 is 3 plus 2J, so complex conjugate will be just minus. That's all. And multiplying like this way, it will be as this, J square will be minus 1. So we get 13. Very easy. Now we go for division of complex numbers. Say we have Z1, Z2, same complex numbers. We want to divide this. How to? This divided by this. We want this, here bottom we will put complex conjugate, because if we multiply these two, then j square will create negative value, only j will be remaining at the top. So what we will do, 3 minus 2j at the top and bottom, numerator and denominator. So we see what is the value comes. Look at here, j square, it means minus, and this 6j will be cancelled. So there will be no j term in the denominator. So easily we get 5 by 13 plus j by 13. That is our answer. So it's very easy to find multiplications and division of complex number. And that's all for today. Thanks for watching.